Hey guys, welcome back. This is the third video on limits. I hope everyone had the opportunity to see the other two videos. And I know they were a bit long, but this one is going to be much shorter. This video is going to be all examples on how to find the limits algebraically. So let's just jump right into it. I'm going to get a different pen, let's say blue. First step in finding limits is direct substitution. You could put the 4 in here, and what you'll notice is you'll get 4 squared minus 16, which is 0 over 0. Anytime you guys get 0 over 0, see if you guys can factor it. That's your first rule. If I get 0 over 0, can I factor the problem? So I could factor it. I can get x minus 4, x plus 4, all over x minus 4. Once you do that, what you're going to do is you're going to cancel out the like terms. So x minus 4 over x minus 4 cancel out, and all you got to do is resubstitute this 4 into what's left over. What's left over is this part, x plus 4. So 4 plus 4 makes 8. So the limit as x approaches 4 of this function here, I'll just call it f of x, is going to be 8. And if you guys remember from the last video, that basically means there's a hole in the graph at 4, 8. Okay, and if you ever want to graph these, you can see it. This here is just going to be this line with the y-intercept 4 and a slope of 1, and it's going to have a hole at 4, 8. Let's try the next one. In the next problem, you plug in 2. The limit as x approaches 2 of this function here. When you plug in 2, you get 0. When you plug in 2, you get 4 minus 4. You get 0. You get 0 or 0, you should try to maneuver it. We know that the numerator is not factorable, okay? Since the numerator is not factorable, we leave it alone. We know the denominator is factorable. What could we do here, guys? We can take out an x. We factor out the x, and what's left over? X minus 2. Once we do that, we're going to cross off the numerator and denominator, and do not forget that there's a 1 in the numerator, okay? That's important. You go back and you plug in your 2 into what's left over. So that's going to be 1/2. So the limit as x approaches 2 for this here is going to be 1/2. Does that mean that there's a hole at 2, 1/2? Absolutely. Let's try the next one. Okay, the limit as x approaches 6. First step is direct substitution. What do we get when we get direct substitution? We get 3 times 6 is 18. 18 minus 18 is 0. 2 times 6 is 12. 12 minus 12 is 0. Okay, let's factor. 3 parentheses x minus 6. 2 parentheses x minus 6. And this crosses off, and you get this function to be 3/2. And basically, guys, if you go and graph this on, let's say, your calculator, your TI-84 Plus or whatever, you're just going to see a graph of a line at 1.5, and it's just going to go straight across, and then when it gets to 6, there's going to be a hole in the graph, okay? So there's no place to plug this 6 in. There's no more x's. So your final answer is just 3/2. Okay, so all three of these functions are going to be reduced to this guy here, or this guy 1 over x, or the 3/2, but there's just going to be a hole in there. Okay, let's try the next one. Now we get to this guy who has a radical in the denominator. So this is a little bit different. We can't factor here. But first, do not skip any steps. You should check to see if it's 0 over 0. So, sorry about that. They're calling me. So let's plug in the 9. X approaches 9. So let's see what happens here. 0 over square root of 9 is 3 minus 3 is 0. So you get 0 over 0. Okay, so what do I do here? Well, what I'm going to do here is I'm going to multiply this by its conjugate. So instead of radical x minus 3, I'm going to multiply by radical x plus 3. Now be careful. I'm going to teach you guys a little trick, but just don't tell anybody. Okay, so here, you're going to leave x minus 9 times radical x plus 3, and you are not going to distribute, or how some teachers call FOIL. You're just going to leave it just like this. I'll show you why in a minute. Do not distribute this. Otherwise, you're going to not know what to do, okay? Now you're going to multiply the conjugates. If you guys remember, conjugates are actually really interesting. In order to figure it out really fast, all you have to do is square the first term, which is radical x squared, which is x, always a minus, square the last term, 9. And if you guys want to pause the video and actually distribute and see if you get the same exact thing that I got, you could. So that's the shortcut. Anytime you want to multiply conjugates, I always tell my students, square, square, square. There has to be a minus sign in the middle, okay? So you just go through the thing, square minus square, okay? Now look what happens. Yay, that crosses off. You're left with radical x plus 3. Well, we know a limit is a numerical value, right? We can't say the limit is radical x plus 3. So what do we have to do now? Well, you're going to have to continue with the problem. Plug the 9 in here. Square root of 9 is 3. 3 plus 3 is 6. So the limit is 6. Okay? So let's try this problem. Let's plug 3 in here. 3 squared is 9. 9 plus 7, 16. Square root of 16 is 4. 4 minus 3 is 1. 3 plus 3 is 6. I did not make a mistake. I wanted to show you how important it is to always stick to the rules. Direct substitution first. Do not look at problems and say, oh, let me multiply by the conjugates. You may not have to, okay? So that's why I put this problem here. Okay, we're almost done. Number 6. I'm going to put a 3 here. 3 plus 1 is 4. Square root of 4 is 2. 2 minus 2 is 0. 3 squared is 9. 9 minus 9 is 0. You get 0 over 0. Is that right? Great. I'm going to multiply by the conjugate. The conjugate is radical x plus 1 plus 2 over radical x plus 1 plus 2. Now, you always multiply out the conjugates, but you never multiply out the other guy. So I'm going to, in my denominator, just leave x squared minus 9 times the square root of x plus 1 plus 2 in hopes that something will cancel out. So let's see. How do we multiply conjugates? Very, very simple. You take the first person and square them. So that person is x plus 1. Then you come to the minus sign, so you put the minus. Then you square the last person, 4. Okay? X plus 1 minus 4 is x minus 3. So nothing canceled automatically, but I know that this guy here can get factored. How do we factor x squared minus 9? It's x minus 3 times x plus 3 times this radical here, which I'm so sorry, I have no room. Okay, so let's cross him off. Cross him off. What's left in the numerator, guys? A 1. Okay, so now let's go back and try to plug the 3 in. Well, 3 plus 3 is 6, so that's a 6 there. And then we're going to plug a 3 right in here. 3 plus 1 is 4. Square root of 4 is 2. 2 plus 2 is 4. We have a 4 times a 6 from here. That's 24. So this answer here is 1 over 24. I apologize about the room. So I hope everybody was able to follow that. If not, watch it again. All right, guys, I'm going to teach you something that is going to blow your mind, all right? So check this out. This is my favorite part of the whole video. This here. I'm just going to combine it into a single fraction. Okay, so let me get this 7, push it down. Come on. Always when I'm about to have fun, it messes up. Okay, whatever, guys. So we know in order to combine fractions, we need common denominators. So right now the denominator is b and d. So all you have to do here is put a d here and a d here and put a b here and put a b here. So this will give you AD plus BC over BD. You might say, yeah, that's great. What's the trick? All right, don't tell anybody this trick. I'm going to just erase this part here. And it was it was A over B plus C over D. all you have to do to combine fractions, don't tell anybody. You go like this. A times D, so that's going to be what I call Chris. Okay? And then I'm going to go, this sign here must be given to him. Otherwise, you're going to get the wrong answer, okay? Always give it to the numerator. So, Chris, A times D, plus C times B, which is BC, because in math we write it alphabetical order. A times D plus B times C, so that's what I call cross. So I go Chris cross. Now, tomato sauce. Tomato sauce, if you guessed it, is going to be B times D. Now, some of you are going to say, oh my gosh, why nobody taught us that? Well, and some of you might say, does this work all the time? Of course it works all the time. The reason why sometimes teachers don't teach you this is because it's not in simplest form, but in many times it will be in simplest form. So I prefer crisscross tomato sauce in order to add fractions. Let's see if we could do the next one, which is this guy. See if you guys could do it in your head. Ready? Chris, that's x squared. Give the negative to him. Cross, you're multiplying these, okay? Tomato sauce. That's how you do it. Or you can stick to your way and do it your way, where you find common denominators. All right, this is why I like to do it for limits. This is our final problem, guys, okay? So I plug in 1. I get 1/2 minus 1/2 is 0 over 0. So I have to combine fractions, okay? So I'm going to go Chris cross tomato sauce. So let me see what that looks like. 1 times 2 is 2. Negative 1 times x plus 1 over tomato sauce, which is 2 times x plus 1. Now I have the bottom, which is x minus 1. Let's clean up the top. You get 2 minus 1 times x, negative 1, okay? And then we got 2 times x plus 1. Now, guys, if you have a fraction over, let's say, a whole term, you can just put that whole term right here. It's like keep, change, flip, okay? So 2 minus x minus 1 is the same thing as 1 minus x over 2x plus 1, x minus 1. Do you guys remember what to do here? I hope so. This looks exactly like this, but in reverse. So we cross them off and we put a negative 1. So now you're going to plug in 1 into what's left over, and you get negative 1/4. And that's how you do that. So in my next video, I'm just going to do some more examples, okay? So come back for the next one.